Good morning, everyone. Hope all is well and everything's all right. Think everybody's in now. All right. So today, I mentioned last class that we would talk about a few things in out of chapter two, and then I will also recap, you know, things that you guys are, responsible for moving forward and due dates and all the good stuff like that. Let's see. Let's go ahead and get to the notes. All right, hold on one second. All right, let's just start right here. Now, in your definitions, so remember you got chapter one and chapter two definitions that will be due. I think I told you guys the 19th. Yep, next Wednesday. You're probably going to come across this, the distribution of your shapes or distribution of your data and these shapes that you will come across. So the first one is your normal distribution or your bell-shaped curve. And so that's the shape right here. And so it's symmetric about the mean. The mean is in the middle. 50% of your data will be to the right of it. 50% of your data will be to the left of it. That's the one that we're going to most definitely be using throughout the course. So you do want to remember this one. The bell-shaped curve is considered your normal distribution. So like I said, you'll come across these shapes when you go about doing your definitions. But it's the next couple of them that people just look confused on. So I just want to make sure we're good. And always when I do my notes, if I'm writing or just giving you guys a chance to copy, if I end up scrolling up and you're still copying, always make sure you let me know so I can either pause, slow up, or whatever the case may be. So you can either unmute and say, could you hold on 1 second, or you can just type in the chat. I'm monitoring the chat as well. So just let me know that. And of course, since I can't see most of you, I wouldn't know if you're still writing or not. So most definitely you should let me know. All right, so the next one, normal distribution. Not normal distribution, excuse me, uniform distribution. So just have the same level of distribution, so it's more like a block. What I'll do is put a All right, so the next one. So one of the ones I want to make sure I emphasize and make sure we're okay with what it means to be skewed left. To me, when I hear skewed left, I always think the opposite of what it actually means. So if your data is skewed left, that means the tail of your data is actually to the left, but the bulk of your data was going to be pushed, to the right. So the tail or the least amount of your data will be to the left. So that's what it means to be skewed left. So always remember the tail of your data is to the left if your data is skewed left. And then the opposite for skewed right. If it's skewed right, then the tail of your data is to the right. And so, of course, the tail means that we're talking about the least amount of your data be to the right. The bulk would be to the left. All right. Any questions on those 4 data distributions? Yep, see a few people jumped up. Appreciate you. All right.
Sorry, Professor, could you go back to the very first one for a second?
Absolutely not. Just messing with you. Is everybody good? Can I scroll up forward? Are they okay? All right. Okay, so that's where we started right there. So, like I said, just want to make sure we were clear on the shapes. Those last 2 where a lot of people, get confused. Just want to emphasize that your tail is what dictates, your skewing, I guess you would say. So if it's skewed left, your tail is to the left. If it's skewed right, the tail of your data is to the right. Once again, this first one is the one that we are going to be using all throughout the course. And certain things we will not be able to do unless we're assuming this normal distribution. So just hold on to that one. Make sure you keep that in the back of your mind. It will come back up. All right. So I think it was Miss Lauren that asked, are you good? Okay. All right. The next one, stem leaf plot. Oh, see somebody in the chat. Middle sheet is the most common sheet. Yep. Mm-hmm. Yep. That's the one we'll see throughout the course. Yep. All right. So your stem leaf plot, your leaves, I said leaves, your leaves will be the rightmost digit of your data value. And then your stem will be all the values that precede that rightmost digit. Yep, not a problem with the confirmation, sir. I don't have a problem with that at all. So if you see the number 53, your leaf will be 3 and the stem will be 5. If we have 127, the leaf is 7 and 12 would be the stem. So once again, your leaf will be the rightmost digit of your data value, digit that's farthest to the right. And then everything that precedes that will be your stem. All right, scrolling up a little. All right, here goes the data set. I'll just write that first. So here's our data set. I wrote it from least to greatest. Of course, your data set does not have to be given to you in order. So, but I just did, went ahead and put them in order for board purposes and everything. So we have 41, 50, 56, 71, 72, 72, 75, 80, 80, 82, 83, 84, 88, 88, 89, 91, 92, 93, 100, 101, 101, 112. So I'll give you a chance to copy that down. All right, so over there in purple, see what I said next is that we have to establish our minimum and maximum values. So this data set goes from the 40s to the 110s. So we see our smallest value is 41, largest value is 112. All right, so I'm going to erase this so we can walk through it. So this is how we will set up our stem leaf plot. Notice we established that our smallest value is 41, largest value is 112. That's why I mentioned that we're going from the 40s to the 110s. And that's how we set up our stems. Because remember, your stems is everything before that last digit, that far most right digit. All right. So from there, we can go ahead and start plugging in the leaves according to the data values that we have. So we have 41. So we put a 1 beside the 4. But that's the only one in the 40s. So then we move on to the 50s. And we have 0 and 6, 50 and 56. There are no values for 60s. So what we do not do is put a 0 here because that represents the number 60. We would just leave it blank. And then continue that pattern, that process, I should say, until you're done with your data set. So 70, 71, 72, 72. So there are two 72s, so there should be two number 2s. And then 75, 80, 80, 82, 83, 84, 88, 88, 89, 91, 92, 93, 100, 101, 101, and then 112. So your stem leaf plot should look this way. All right. Questions on what we did there? All right. So when it comes to stem leaf plot, if you look at it, it's just another way of representing a bar graph. If you were to take it, see that you have your bars right here. So you could have represented it, as a bar graph or histogram. And so you may ask yourself, well, why would you do this versus doing a bar graph, histogram, or something along those lines with pictures and colors and everything? Well, it depends on your audience. When it comes to statistics and graphs and everything like that, you really should be looking at your audience and what's more appealing to them. If you're dealing with people who like numbers, then this would be more appealing to them. If you're dealing with a liberal arts type of audience, then the graphs and the pictures and the colors would be more appealing. So it's just about trying to appeal to your audience, but it still gives the same amount of information. All right, you want to scroll up for 2 seconds. How far up? Let me see, let me know in the chat if I go up too far or that's where you want to be. I guess you'll let me know in a second if I'm good or not. So let's see. Okay, cool. So when it comes to stuff like that, it's all about your audience and what you're trying to do in your presentation. So with statistics, what you'll start to realize once you really get into it, I know you heard the saying that numbers never lie, but the other part of that is that they can mislead. And you'll see that if you really get into statistics, you can actually use the same numbers to say whatever you want to say, creating opposite arguments if you know what you're doing. That's why when you hear political statements about this and that, and this president did this and this president did do that or whatever, I never really get too involved or invested, because if you really know statistics, those numbers can be flipped and you can get them to say what you want to say. For example, you'll get into your definitions and it should mention outliers. I think in chapter 2, they mention outliers. Chapter 3 will actually do some work with them. Outliers are just very, very large numbers or very, very small numbers in comparison to your data set. So at some point, they'll tell you when you'll run your numbers with the outliers and then run your numbers without the outliers. So that means, and then whichever one fits your argument best, that's the data set that you'll use, or that's the experiment that you'll use. And so you give all the numbers, and if somebody look at your numbers and say, well, I see you left out these numbers, well, you can say they were outliers. And then, but if you look at these numbers and then everything says what you want to say, you include them, and you say, well, somebody say, well, what about these numbers? They're outliers. But then you can say, but they were a part of my observations. They were a part of my data set. So it's like you have a reason to use them or a reason not to use them. And so statistics can be funny that way, but it's really about using these data values to your advantage to present your case, present your argument. All right, sway people into your direction. Oh, that was it? Okay. So as you can see, my drawing is not the best. So that's why I said when it comes to graphs, make sure you take a look at them. See if you have any questions. Anything you ask or any questions you have, there'll be room for you to ask them. So make sure you get those questions in if you have them. Right now, what you're responsible for, chapters 1 and 2. We have definitions, and they are due on the 19th. All you gotta do is email them to me, whether it be you write them down in your notebook, take a picture, send them to me. For some reason, your file, if I can't open them or anything like that, I'll let you know. Or you can download it from MathLab, and let me show you for anybody, this may be your first day here. Let me go in there and show you where they're located. And these definitions, like I mentioned last class, are not, it's not an assignment that's supposed to fry your brain or anything like that. It's easy assignment, easy 100 to start the semester off right. All of your data, not all your data values, but all of your terms are in your book, your e-text. All of them are in a row, lined up in rows, not as in rows, lined up in order. And yeah, it should be an easy assignment. All you do is familiarizing yourself with these terms. And so definitions 1 and 2 are right here. Click on it. Definitions 1 is 3 pages. Definitions 2, though, is just 1 page. All right, that's because majority of chapter 2 is about graphs. All right, let's see what else I need. Oh yeah, textbook is right here. Either chapter contents or e-text. Both of those take you to the book. And so, and all of your, like I said, all of your definitions are in order. And so you don't have to go Googling or anything like that. And if you have access to MathLab, then you have access to the text. Also, if life happens and you can't get it to me by the 19th, all it takes is an email, communicate. It's all good. Let's talk about it and make sure you have this grade in there. You don't want a 0 for no reason, okay? But that is the due date that we're looking at. So we also have, MathLab homework for chapter 1 and 2. And that test, I should have written that test right here. Test 1 also has 1 and 2. So that's what we're looking at for chapters 1 and 2. Your definitions, remember, well, I won't say remember, for those who weren't here first day of class, I'm not giving a real lecture on chapters 1 and 2 because it's majority definitions. Those definitions that I assigned to you guys will pretty much, for the most part, be repeated in your MathLab assignments. And then your tests will be based on that as well. So chapter 1 and 2 are definitions and graphs. And that's why it's not really a lecture on it, because all I would be doing is writing down those terms and you would be copying them. So like I said, to eliminate that process of all of us falling asleep during this time, you guys can just do it on your own. Shoot me that doc, and then we'll go from there. So this is a good spot for us to be in, because not only are we, you have this time to do chapter 1 and 2, but also we don't have class on Monday. So that's more time for you to knock out chapters 1 and 2 without me giving you anything else. So hopefully, we can come into Wednesday with a clean slate, ready to knock out chapters or get started with chapter 3. Questions. So that's when the real lecture, we'll get into a real lecture. Chapter 3 is not heavier content. So, with mean, mode, and median, some of you may have already seen stuff like that before. That's what we get started with. So I just want to make sure we're okay with the dangers of this course. Chapter 1 and chapter 2 definitions, you're like, all right, I get to it, and I get to it. Chapter 3 is only 4 sections, so one class. So we could actually do all of chapter 3 in one sitting. So I'm not gonna do that because I don't want to overwhelm you with work to do. But we'll do 3-1 and 3-2 Wednesday, and then come back and do 3-4, 3-5 the following Monday. But then we'll be done with chapter 3. So then you have 3 chapters, that you're responsible for. Well, chapter 4 is only 3 sections. So that means we'll be done with chapter 4. Next thing you know, we're in chapter 5. So be careful. Make sure you are knocking these things out. I know you don't want me to create more stuff for us to just be doing sitting in a chapter. So I'm going to try to pace this thing out. But that means you have to be on top of this homework. And you don't want to be sitting back too far. All right. So I said I need to check my holidays.
I do have a question though.
Yes.
They would take attendance today?
I will take attendance off of math lab activity. So
Okay, cool.
it's just easier for me to do it that way because sometimes I have people that come in late, and then
Right.
so instead of me trying to comb through comb through names, like in other words, I would have to, all right, guys, wait a second, I got to take attendance. You know what I mean? Instead of holding you guys up and stuff like that, it's just easier for me to go to math lab and look at the fact that you guys were active in math lab and then take attendance off of there.
Okay, thank you. That answers my question.
Yep, not a problem at all. So for anybody else who may be wondering about that attendance thing, I look at it weekly. So if you and I mentioned this first day of class, so if you didn't hear the first day or miss first day, I just need you to go in there. If let's say you weren't able to get some work done in math lab this week, cool. I need you to at least go in there, go into a homework assignment, hit save, and come out. At least do that, because that gives me a timestamp on your attendance and your participation. And that lets me know you're still here, still around, doing stuff. If I don't see that, then it will be tough for me to stay on top of your activity in this virtual world. So yep. Like I said, nothing else, just weekly going there, going to an assignment, hit save, and then come out. Do not go into a test and do that, because it will record your test. But remember, your homeworks are unlimited. So you have unlimited amount of time to get the best grade possible. And when it comes to a test, I'll say this too, and then I will be done. If you're taking the test, and let's say you thought you were ready to take it and you're not, or you got in there, your brain is fried because you did all this homework, you're just done with it. What you can do is don't log off, don't hit save, don't hit submit. And I'm talking about just for test homework, you're free to go in and out. But for your test, what you would do is just hit the red X, just close it out. Just close out the window. It would treat it as if an interruption occurred, or like a blackout or something like that, and it will let you pick up where you left off. All right, so that's just for your test. Homework, you can go in and out freely. But if you go into a test that's not being proctored, that you're taking on your own time, that's not being timed, that's how you circumvent the process. Just hit that X button, close out. Once again, don't log off, don't hit save, don't hit submit. Just close out that X, and then that will let you pick up where you left off when you come back in there. Also, a warning: if you do try this in another class, I cannot be responsible for what happens. I know I've had students that will come back and email me the semester later. It's like, Mr. Tuck, I tried this in another class, it worked. Okay, but I didn't tell you to do that. All I know is what's going on in my class. It may or may not work. So just let you know. All right, any questions, concerns, comments before we close out today? Everybody good? Everybody straight? All right, so you guys know what you have to do. If you have any questions, feel free to shoot me that email. Yeah, that's it. So have a great weekend, be safe, have a great holiday, and I will see you on Wednesday.
All right.
Have a nice day.
Thanks, you do the same. Take care.
Okay.
Thanks, do say, take care, take care. All right, so did you have a question?
Oh, yes, can you hear me?
Uh-huh.
Okay, yeah, like, so I put in a lot of thought and I thought, I don't want it, I'll rather, I decided to purchase a new, I, I purchased a new student access code.
Okay, yeah. Mhm.
Because I just want to save all the hustle. I